между третьим и четвертым.
А там люди есть?
Да,
Поднимай на состав.
поднимаю. Начальника поднял.
Так всех, весь офицерский состав, офицерский корпус поднимай.
Леонид Алексеевич.
Да.
Алло, Припять, третий и четвертый блок горит крыша в результате аварии взрыва.
Ой, давай. Так уже подтвердили?
Не подтвердили, авария там произошла у них. Это диспетчер Припяти сказала.
At 1:23 a.m., everything was still normal. The reactor was running. The control room was calm. The engineers were following procedure. No alarms warned them of disaster. No system screamed that something was wrong. Because what was about to happen wasn't considered possible. The Chernobyl disaster did not begin with an explosion. It began with a test designed to make the reactor safer. And within minutes, that experiment would turn one of the most advanced machines ever built into something no one could control. To understand what happened, you first need to understand why Chernobyl mattered. By the 1980s, nuclear power was seen as the future. Clean, powerful, efficient. A single reactor could power entire cities. Chernobyl was part of that promise. Reactor number 4 was not experimental. It was operational, productive, trusted. Engineers believed nuclear reactors were predictable systems. If temperature rises, power goes down. If power increases, control rods stop it. If something goes wrong, automatic safety systems intervene. Everything had a response. Everything had a backup. On paper, this was engineering at its best. But paper does not react. Real systems do. On April 25, 1986, Reactor 4 was scheduled for a routine shutdown. Nothing unusual. During this shutdown, engineers planned to perform a safety test. They wanted to know whether the spinning turbines could provide temporary power to safety systems during a blackout. It was a reasonable question. In fact, it was a necessary one. Previous attempts work, but delays pushed the reactor into an unusual operating condition. Power was reduced later than planned. The reactor stayed online longer than expected. Still, nothing felt dangerous. This is important because disasters don't happen when people feel afraid. They happen when everything feels normal. As power was reduced, the reactor slipped into a low-power state. This is where things quietly changed. At low power, this reactor design became unstable. Operators tried to increase power again. Control rods were pulled out, more than allowed under normal safety margins. Still, procedures were followed. Still, no alarms screamed disaster. But the reactor was no longer behaving like engineers expected. It was sensitive, unpredictable, like a machine balanced on the edge of a cliff. And yet the test continued. To run the test, several automatic safety systems were turned off. This is often misunderstood. They weren't disabled out of recklessness. They were disabled because they would interfere with the experiment. This was allowed, approved, documented, and this is where engineering confidence becomes dangerous. Safety systems protect you from failures you expect. They do nothing against failures you believe cannot happen. At this moment, the reactor was operating. At low power, with minimal control rods, with key protections offline. It was still running, but it was no longer safe. Here's where the real problem reveals itself. The RBMK reactor had a flaw that few fully understood. Under certain conditions, as water turned into steam, the reactor became more powerful instead of less. This is called a positive void coefficient. It made the reactor harder to control at low power. But there was another issue. The control rods had graphite tips. When inserted, They briefly increased power before reducing it. Engineers knew this. What they didn't know was how dangerous it could become under the exact conditions that now existed. Everything still looked correct. The system was doing what it was designed to do, just not what anyone expected. At 1:23 a.m., the test began. Almost immediately, the reactor surged. Operators pressed the emergency shutdown. Control rods began entering the core. Instead of calming the reaction, power exploded. Fuel channels ruptured. Pressure spiked violently. In less than 4 seconds, the reactor exceeded its limits. An explosion tore through the building, then another. The reactor core was exposed to open air. This was not a meltdown. This was total loss of control. In the control room, no one understood what had happened. Instruments failed. Readings contradicted each other. Some believed the reactor was intact. It wasn't. Firefighters arrived without protection. Radiation had no smell, no sound, no warning. Debris on the ground was emitting lethal doses. The danger was invisible and spreading. What followed was disbelief. Inside the control room, senior engineers struggled to understand what they were seeing. A nuclear reactor exploding was considered impossible. Anatoly Dyatlov, the deputy chief engineer overseeing the test, initially refused to accept that the reactor core had been destroyed. He believed the readings were wrong. He ordered water to be pumped into a reactor that no longer existed, because accepting the truth meant accepting something unprecedented. Firefighters arrived within minutes. They were led by Lieutenant Volodymyr Pravik and Lieutenant Viktor Kibanok. They believed they were responding to a conventional industrial fire. They climbed onto the roof of the reactor building. They moved burning debris by hand. What they were touching was graphite from the reactor core. Radiation levels in some areas exceeded 10,000 Roentgens per hour. For comparison, a dose of 500 Roentgens is typically fatal. Many firefighters received several times that amount. In minutes, 28 first responders died within weeks from acute radiation syndrome. Others would suffer lifelong illness. Radiation does not kill loudly. It dismantles the body from the inside. Inside the plant, radiation instruments failed. Most dosimeters maxed out at 3.6 Roentgens per hour, giving a false sense of survivability. In reality, radiation near the reactor exceeded 30,000 Roentgens per hour, enough to kill a human in under a minute. But the instruments could not display that, so decisions were made in the dark. As the reactor burned, radioactive material was released continuously. The fire would last 9 days. Isotopes like iodine-131, cesium-137, and strontium-90 were carried high into the atmosphere. The total radioactive release is estimated to be hundreds of times greater than the Hiroshima atomic bomb. And still, no evacuation was ordered. In the nearby city of Pripyat, home to nearly 50,000 people, life continued. Children played outside. People went to work. Families watched the glowing reactor from a nearby bridge, unaware they were receiving dangerous doses of radiation. Evacuation began 36 hours later. Residents were told to bring documents and essentials. They were told they would return in a few days. They never did. Pripyat became a city frozen in time. 2 days after the explosion, radiation alarms went off at the Forsmark Nuclear Power Plant in Sweden. Workers were contaminated, but the source was not local. Air samples confirmed it. The radiation was coming from the Soviet Union. Only then did the world learn that something catastrophic had occurred. Attention now turned to a terrifying possibility. Beneath the destroyed reactor lay molten nuclear fuel, corium, burning downward. If it reached the water reservoirs below, it could trigger a massive steam explosion. Some estimates suggested it could contaminate vast areas of Europe. Preventing that became the next critical engineering challenge. 3 men volunteered to enter the flooded chambers beneath the reactor: Alexei Ananenko, Valery Bespalov, and Boris Baranov. They navigated dark, radioactive corridors to manually open drainage valves. There was no certainty they would survive. They succeeded. The water was drained. The risk of an immediate steam explosion was dramatically reduced. All 3 survived the mission. Another threat remained. If the molten core continued downward, it could contaminate groundwater feeding the Dnieper River, a water source for millions. Engineers proposed an extreme solution. They would dig beneath the reactor and install a massive concrete heat barrier. Coal miners from Tula and Donbass, led by engineer Mikhail Shadov, were brought in. They worked in extreme heat, with minimal protection, under constant radiation exposure. They dug day and night. In the end, the molten material slowed before reaching groundwater. But at the time, no one knew it would. They were planning for the worst-case scenario. Over the following months, more than 600,000 people, known as liquidators, were involved in cleanup and containment. Robots failed due to radiation damage. Humans replaced them. Some worked in 90-second shifts on the reactor roof, the maximum survivable exposure. Many paid with their health, some with their lives. By November 1986, a massive concrete structure, the sarcophagus, was completed around Reactor 4. It was rushed, imperfect, temporary. Decades later, it began to crack. In 2016, a new structure, the new safe confinement, was placed over the reactor. It is designed to last 100 years. The radioactive material inside will remain dangerous for tens of thousands. The human cost of Chernobyl remains debated. Official figures list 31 immediate deaths. Long-term studies estimate thousands of thyroid cancer cases, especially in children, hundreds of thousands exposed. Long-term deaths ranging from several thousand to tens of thousands, depending on methodology. Entire regions remain uninhabitable. Hundreds of villages were erased from maps. An exclusion zone still exists today. Chernobyl permanently changed nuclear engineering. Design flaws were acknowledged. Safety culture shifted. Assumptions were questioned. Not because engineers became careless, but because they learned something fundamental. A system can follow every rule and still fail catastrophically. Chernobyl was not caused by stupidity. It was caused by belief. Belief that the system was fully understood. Belief that uncertainty had been eliminated. Belief that the impossible would remain impossible. The reactor failed in seconds. The consequences will last centuries. And that is the true legacy of Chernobyl.